is Henrik Zetterberg. I'm a professor of neurochemistry at the University of Gothenburg. And I also work in London and in Madison, Wisconsin, where I run a couple of fluid biomarker labs focused on neurodegenerative diseases, for example, Alzheimer's disease. The focus of my research is to improve the molecular diagnostics of brain diseases. I've been working a lot with Alzheimer's disease, but I don't have a particular disease focus, so anything we can measure that relates to brain health or brain function in biofluids, that is the focus. In the next few years, we will see what happens if you identify people who are still cognitively intact but have Alzheimer's pathophysiology in their brains. And if you then go in and intervene there, what happens then? We don't know, but it would surprise me if it wasn't a better effect, and perhaps also that the side effects would be less intense in that early stage of the disease. I am very interested in also trying to see if we could use these biomarkers to determine who is likely to be a responder to certain drugs. And there we are not there yet, but I think that will happen in the next few years, actually. Responders and non-responders. Tailoring drugs to specific individuals, combining also with perhaps lifestyle intervention and other things to improve the health of people in a very molecularly specific manner. So the low concentrations of most of the proteins we're trying to measure, that is and remains the main challenge, but thankfully there have been wonderful technological developments which has made this possible to do. And another challenge that has been a bit harder to resolve is that some of the proteins are not brain specific. So when we move from the CSF, where you can say that the concentration is very likely to reflect what's happening in the brain, when we move from CSF to blood, the blood could be contaminated with protein released from extracerebral sources. And then the measurement can be super good, but we still can't draw conclusions what's happening in the brain. Then there are ways of figuring this out, for example, by working with neurally derived extracellular vesicles, perhaps proteins, brain-specific isoforms of proteins. And that's exciting, difficult, but also it's interesting. And without these types of challenges, anyone could do this and it wouldn't be that fun. I heard about the technology 2.5 or 3 years ago. We often do like this when new players come in and discuss with us. We send blinded samples and ask for results back. And we have been developing individual assays for different phospho-tau forms, which is a Alzheimer-related protein abnormality, and also some other markers where we knew that the assays worked. And those markers were also on the CNS panel by NULISA. And again, within a few weeks, we got results back, we unblinded, and we saw that the correlations were superb. And also that the analytical sensitivity looked better than some of our assays that we had developed. And then the wonderful thing with the technology is that if you have these types of very sensitive measurements that are precise and accurate, and you have the multiplex, you can measure many, many more proteins in small volumes. And when you have built a biobank with samples from patients, you do not want that biobank to go empty. So this made it possible for us to interrogate biobanks for a much broader panel of protein biomarkers than we have ever been able to do before. And then we can look at what the biomarker-specific information you can get from individual biomarkers, but you can also see what happens if you combine them. And that has been extremely powerful. It was super easy to integrate NULISA in the lab. Of course, our lab is specialized in ultra-sensitive biomarker measurements. So we have experience with most of the immunoassay platforms that are around, and also mass spectrometry. Some of the PhD students and technicians complained that it was almost too easy. But that was when we used the established panels. Now we are also, thanks to the home brewing capability on NULISA, making our own assays. And then it becomes, interesting to do the work also in a specialty laboratory. So being able to do established panels, but also develop new tests for new proteins that might be favorite proteins in our lab for one reason or another. That is, I think that is extremely exciting. So in 5 years' time, I think we might have a neurology panel, so which could be used whenever a patient comes to a neurologist because of worry for progressive neurological symptoms. It doesn't have to be memory, it could be something else. Then one could do this panel and rapidly determine to what extent there is amyloid, tau, neurodegeneration, TDP43 pathology, alpha-synuclein, and cerebrovascular disease. And in 10 years' time, perhaps this will have been expanded even further with additional age-related diseases. So I think this multiplexing, incorporating many important biomarkers into one measurement, basically, I really like that.